Okay, so when we talk about finding the inverse of a function, the inverse of a function is basically just when we take the x and the y values and we switch them. Okay, and then the second sentence is not. It's just telling you what it looks like. So if I want the inverse of f of x, I'm always going to write it like that. So it looks like f to the negative 1 of x. That doesn't mean we write it as 1 over f. It just means that's the inverse. So when I ask for that, I'm going to say find f negative 1 of x. That means find an f inverse of x. Okay? So we're going to start by taking a look at some ordered pairs. We are going to write the inverse of the function. And then we are going to decide if that inverse is also a function, which would mean it is 1 to 1 like we talked about yesterday, right? Okay. So my ordered pairs are 2, 1, negative 3, 4, 1, 0, negative 4, 2. And again, to find the inverse, all we do is we switch our x and our y values. So f inverse of x is going to be, I'm just going to take each ordered pair and basically switch the x and the y values positions. So if my first ordered pair is 2, 1, it would turn into 1, 2. Okay, you just switch them. And then if the second ordered pair is negative 3, 4, it would turn into 4, negative 3. Yep. If the third one is 1, 0, it would turn into 0, 1. And then the fourth one is negative 4, 2, so that's going to turn into 2, negative 4. Okay, all I did was rewrite the ordered pairs and switch the x's and the y's. So then it asks, is that a function? My new x values used to be the what? The y values. You remember yesterday when we talked about deciding if it was 1 to 1, we always looked at the y values to determine. That's before we switched them, right? So if I look at all my new domain values, that used to be my y values, 1, 4, 0, 2. Is that a function? Yes. Okay, so do the same thing with the second one. I just want you to write the list of ordered pairs as the inverse of that function. So the inverse of h is what it's called. And again, to find the inverse, we simply switch the x and the y's. So the inverse of h, okay, you can write it like that with a colon in between, is going to be, what would my first ordered pair look like? 4, 2. Okay, my second one? Third one? 4, 8. And then the last one would be 0, 1. Is that a function? No. Okay, because I have a new, my new domain values, I have 2 of them that are the same. So pretty easy with ordered pairs, right? You just switch. That's how you find the inverse. Everybody ready? I see. Okay. Next, what I'm going to do is I'm going to give you an equation, and I'm going to ask you to find the inverse. And there are 4 steps that you're going to want to write down. These are going to be the steps that you follow to find the inverse of each function or each equation. If you want to take a minute, write those steps down. And then we will go through a few of these together. So this is going to be what it does when it says find f inverse of x. These are going to be the 4 steps that you follow. Step 1 says we replace f of x with y. We've talked before about how f of x is equal to y. They're the same thing. Then after you do that, you're going to take the x and the y in your equation and you're going to switch the position. So basically, wherever there's an x, you're going to put a y. Wherever there's a y, you're going to put an x. Then after you switch the positions of x and y, you're going to then solve that equation for y. And then once you get that equation solved for y, you're going to replace that y with the f inverse of x notation. So we're going to replace f of x with y. We're going to switch x and y. We're going to solve for y. And then we're going to now replace the y with the f inverse of x. Everybody ready? All right, here we go. Start with number 1. We'll start with a real easy one. My equation that I want to find the inverse of says f of x is equal to 2x. First step says to what? Replace f of x with y. So I'm going to change my equation to y equals 2x. Then the second step tells me to switch the x and the y. So where the y is, I'm putting an x, and where the x is, I'm putting a y. And then the third step says to solve for y. How would I solve this thing for y? Divide by 2. So I get y equals just x divided by 2. And then what was that last step? To take that y and replace it with f inverse of x. Yep. Everything else stays the same. So that would be the way my final answer should work. F inverse of x is equal to x divided by 2. Everybody kind of okay with that one? Now, I want to talk to you about why it works the way it works. Look at this equation. If my function is equal to 2 times x, right? Isn't that what 2x means? When we solve equations, we always use inverse operations. What is the inverse of multiplying? Dividing, right? Well, what did my inverse end up doing? It took my x, instead of multiplying it by 2, it divided it by 2, right? That makes sense that it's the inverse then? All right, I want you to try 2 by yourself. Replace f of x with y. Switch the x and the y. Here, I'll write them up on the board. Replace your f of x with y. Except for it would be y equals 3x plus 2, and then it would be x equals 3y plus 2. So just what Again, replace f of x with y. Then I'm just going to switch the x and the y. So where the y is, I'm putting an x. Where the x is, I'm putting a y. Is everybody okay with that so far? Then I need to solve for y. What would I do first to solve for y? Subtract 2. So I get x minus 2 equals 3 times y. And then what would I do? Divide. Just when you divide, make sure you divide that entire thing, the entire x minus 2 by 3. Not just the x and not just the 2, but both pieces. So then I end up getting, I end up getting y equals x minus 2 divided by 3, which then the final step is to just replace that y with the f inverse of x, and you can leave everything else the same. So if you think about it, in your original function, we were multiplying by 3 and adding 2, right? What's the inverse of adding? Subtracting. Didn't I end up subtracting? And then dividing by 3 instead of multiplying by 3? Does that make a little bit of sense? Okay. All right, we're going to try 3 together because this one's slightly different, but also not really. If you'll write the function down, go ahead and replace your f of x with y. Then we're going to switch the x and the y. Okay, so again, replacing f of x with y. And then just because the x has an exponent on it doesn't mean anything changes. We're still, wherever there's a y, we're putting an x. And wherever there's an x, we're putting a y. Okay, the exponent is going to stay with the switch. It's not going to stick with the x. It's going to stay with where the x used to be. Everybody okay with that? All right, then what would I do to start solving for y? Add the 8, yep. So I get x plus 8 equals y to the third. How do we undo raising something to the third power? Cube root, yep. So we're going to take the cube root of both sides, and again, in its entirety. So that would end up giving me y equals the cube root of x plus 8. And then what's the final step? So we're going to replace that y with the f inverse notation. Try 4. It's similar, but also slightly different. Maybe refresh it should be. All right, we're going to replace f of x with y. Then we are going to switch the x and the y. Now, let me ask you this. In order to be able to solve this for y, do I subtract the 7 first? No, what do I need to get rid of? The square root. And how do I undo a square root? You square it. So we're going to square both sides. And remember, that square is going to make that square root cancel. So now I'm just left with y plus 7. What would I do next? Subtract the 7. So I'm going to get y equals x squared minus 7. And then the last step is to replace that y with the f inverse of x notation. Okay with that. Okay. Now we still have another thing to do, but I want to talk just a second about the homework too, because the directions in the homework, I don't want you to do all of that. So the stuff like this, like these first 4, is going to be your the 43 through 49 odd, but the directions tell you to state the domain and range. Don't do that. All I want you to do is find the inverse equation. I don't want you to worry about domain and range for those, okay? So when you're reading the instructions, and I even put it on Canvas, I said don't do domain and range. So just find the inverse, and that's for the second part, right? And then the first part, it says don't graph, because the instructions are telling you to graph. We're not graphing anything. We're just worrying about inverses. Okay. So the next thing we're going to do is we are going to prove that 2 inverses are functions of each other. And it tells you how to do that in that first little piece up top. So if you want to write that down, and then I will explain what that means. We're going to be given a function, and we're going to be given something that says it's the inverse of a function. And what we're going to have to do is prove that. And the only way to prove that is by showing your work. You can't just say yes, you got to actually do the work. So we're kind of going to be using those composite functions that we did the other day to prove that these are inverses of each other. So basically what you have to do is you take your inverse function and you plug it in to your original function for x. Okay, that's what f inverse of x means. And when you simplify it, it should equal x. Then you're going to reverse. You're going to take the original function and you're going to put it in place of x into the inverse function. That's what that second part says. F inverse of f of x should also simplify to be x. So basically you're going to take each function, plug them into each other 2 separate times. If they both simplify to be x, then they are inverses. If they don't both simplify to be x, then they are not inverses. Ready to try? Okay, if you haven't already, go ahead and write down the 2 for number 5. We have f of x is equal to x minus 2 divided by 3. And then we have f inverse of x is equal to 3x plus 2. Everybody ready? So we're going to start by doing f of f inverse of x. So what that means is I'm going to take this entire f inverse function and I'm going to put it in place of x into the f function. Just like we did a few days ago. Okay. So instead of this x, I'm going to put all of that stuff. So what would I put? 3x plus 2. And then what's behind that? A minus 2. And then below it is 3. Does everybody understand what I just did? I took out this x and I replaced it with what the inverse was. So the function is still the same. I just took the x out and put the inverse function in its place. Now, let's simplify that. If I have at the top 3x plus 2 minus 2, what does that simplify to be? 3x. And then if I have 3x divided by 3, then that simplifies to be x. That's what I'm looking for. If it doesn't simplify to be x, I can quit and automatically say no. But if the first one simplifies to be x, I'm going to have to reverse and do the second one the same. So this time, I'm going to do f inverse of f of x, which means I'm going to take this entire thing and put it in place of x here. So my f inverse function is 3, but then instead of x, I'm putting that entire fraction. So I'm going to put x minus 2 divided by 3. And then plus 2. Does everybody see what I did? Took the x out of the inverse, put in the original function. Now, if I multiply 3 by something over 3, what happens to those 3's? They cancel. Okay, so that 3 is going to cancel with that one, leaving me with just x minus 2. And then I have that plus 2. And what does that simplify to be? X. Okay, so here's my proof that both of them simplify to be x when I do the composite function either way. So therefore, yes, this is a function. I mean, these are inverses. Sorry, not a function. Does that make a little bit of sense? You take one, plug it into the first one, simplify it down. If it's x, keep going. If it's not x, you can stop and say no. Then you take the first one and plug it into the second one. If that simplifies to be x as well, then you can say yes. Everybody ready to try one? All right, try 6. Give you a little bit less work to do. This is going to be like 25 through 29 odd. Again, it's going to tell you to graph. Don't worry about graphing. Yeah, but you gotta like show your work to prove it though. That's what it says prove, so you gotta do the work. So you take this and put it like this. So that just equals. That's your proof. Now, I know with some of these, especially knowing what inverse means with your math, that you can kind of tell that they're inverses of each other. But again, it says to prove it, so you actually got to do the work. Plug it in, simplify it out, show me that it's x. So I'm going to start with the first one. F of the inverse. So again, I'm taking the inverse and plugging it into f. So this entire thing goes in place of x. So that would be the square root of x, but then what's still attached to it? I put a 2, sorry. Try that one more time. But the exponent 2 is attached to it. And then if I simplify that, what happens when I square a square root? What do those two do to each other? Cancel, so that just leaves me with x. Okay. Then I'm going to do the opposite way. I'm going to do f inverse of f of x. So I'm going to now take this entire thing and put it in place of x here. So it would be the square root of not x anymore, but x squared. And if I take a square root of a square, those two just cancel and leave me with x. So there's my proof. Are those two inverses of each other? Yes. Okay, again, that one was kind of easy to look at because you got a square and a square root. We know that those are opposites of each other. Okay, but the proof is in what we just did, plugging it in, simplifying it out to be x. Last one. try that one. Again, when you're working this out, if the first one does not simplify to be x, there is no reason to even do the second one because your answer would automatically be no. If the first one simplifies to be x, then you have to keep going. Start with the first one, f of f inverse of x. That means we're going to take this entire thing and we're going to put it in place of x there. So it is going to be 4 times that entire fraction and then minus 5. When I multiply that first part, does that 4 cancel with that 5? No, it basically gives me, oh gosh, you multiply those two, that's going to be 4x plus 16 over 5 minus 5, right? If I wanted to do that subtraction, what do I have to turn that 5 into? I have to turn it into a fraction, right? With a denominator of 5, which would give me 25. Now, if I start working on that, if I do 4x plus 16 minus 25 over 5, that gives me 4x, what is that, minus 9? 40. 8? 9. Okay, I was like, I'm sitting there counting in my head like, does that simplify to be x? No. So is there any need for me to even do the other option? So would these two be inverses of each other? No. Okay. Because I did that first one, it did not simplify to be x. There is no need for me to go any further. I can automatically stop and say, no, those are not inverses of each other. Anybody have any questions? Okay. Again, on the homework,